adjustments or monitor it for health monitoring capability. Similar to our S-series systems, 240 volt AC single phase input, again fully integrated and network ready as well, connected into your existing intranet. Hydrogen purity control to greater than 99%. Dew point raise of less than minus 20 degrees F to control the electric generator cavity below those levels, which is OEM targets, and maximize stable pressure inside the electric generator cavity. So the stable flow system primarily monitors pressure, and it does that because we're making adjustments to purity and dew point by changing the scavengery. If for some reason there is an interruption in your hydrogen supply for whatever reason, by scavenging more, we could reduce the pressure inside the generator cavity, which you do not want, correct? So the stable flow systems, the hierarchy of the control looks at pressure first. It says, is the pressure within the band that I want to be in? If it is, then it says, okay, let's look at purity. If purity is outside our target band, we'll make a scavenge rate adjustment. And similarly, it would do the same thing for dew point. And so over time, we're changing the scavenge rate, letting out-of-spec gas out, bringing in fresh gas into the generator cavity, and therefore maximizing purity, minimizing dew point, with the safety consideration that pressure is always within the band that we want to operate in.
Does that have the ability to display essentially your usage rate, negating what you're taking out for scavenging?
It can be, yes, it can be configured that way. So you could take into account what the hydrogen generator, for instance, the hydrogen generator is making, and then take out what each stable flow might be using, and the result is whatever your leakage rate is. So you got a nice health monitoring capability there. Now the nice thing about that too is you could integrate it such where as you dig into it a little further, you can say, look, I'm typically at 500 cubic feet a day. Now I'm at 1,000. Something must have changed. Is it in my electric generator or is it in my piping? So it's another health monitoring for the integrity of your hydrogen manifold within your plant. Again, a safety capability there. So that's the kind of the heart of the stable flow system, and it's kind of the evolution of where it came from. This is a typical power plant implementation. Your electric generator here is kind of at the center of the process. On the feed side of your hydrogen system, you've got either your high pressure cylinder storage or low pressure tank or high pressure tube trailer here into your existing manifold. And if a on-site generation solution was incorporated, it would just plumb into your existing manifold. You could locate it inside the plant and not classify the space as hazardous, and locate it near the utilities that you need. Deionized water or demineralized water, ACW, in your hydrogen manifold. And bring in electricity, and you're up and running. So this is all on the supply side. On the outlet side, or the sample side, is where the stable flow system is located. And it taps into your existing sampling system for hydrogen purity monitoring, or perhaps if you monitor differential pressure on the fan, generator fan, you can tap in there as well. And we just take a constant sample of hydrogen from that line, look at purity, dew point, and pressure on that line, and then again make adjustments to the scavenge rate to increase purity and drive dew point down. Again, the stable flow system is designed such that it's fail-safe, so if you ever lost power to the system for whatever reason, the valves are all spring-loaded closed, they're normally closed valves. So in that situation, you wouldn't interrupt the operation of the electric generator at all. You would just no longer be quote-unquote optimized. So there's no fear that you're going to upset the electric generator operation and see a power failure to the stable flow or something like that.
Does that give like a printout on your scavenging dew point? Like so you can tell if you got a hydrogen leak, cooler leak coming in or something like that?
It doesn't give a printout, but what it does have is 4 to 20 milliamp output. So you can connect in pressure, purity, dew point.
You can trend it and track it if you want to.
Yep, yeah, and scavenge valve position. Just bring that right into your DCS. So,
it gives you scavenging dew point too.
It'll give you scavenge valve position, yep, and from that you can calculate.
Is the valve position or is it actually sense of dew point?
It senses dew point,
Okay,
senses dew point, senses purity,
okay.
senses pressure, and then we've got the valve position, and from that you can calculate scavengery. Again, that all goes into DCS and you establish a baseline and then look at it over time. So just a couple quick installation pictures. Again, an S-series system, 480 to 240 volt transformer for the unit, D-main water coming into the unit, power disconnect, hydrogen product line, under voltage surge protector for this application, condensate trap on the vent side of the system. The important just safety benefit of the on-site generator. The generators are designed to be fail-safe as well. So if there's ever a power loss to the generator, it completely shuts off and it completely depressurizes. So within 5 seconds after we lose power, the system would be depressurized. And that just goes out this condensate trap vent, out your existing vent infrastructure. So from a safety aspect, it's completely safe and you don't have inherent pressure sitting inside the system. Similar connections for the larger H-series system. Just the main AC power coming in here on the right-hand side of this cabinet. Also here you would locate any Ethernet connection that you wanted to have, also on this side of the cabinet. And then here on the left-hand side, the plumbing side is here. And you have a deionized or demineralized water drain from the system, your cooling water supply and return from your existing ACW. D-min water supply, in this case just going through an extra guard bed for water quality purposes, maintaining water quality purposes. Your hydrogen product line up here, and your hydrogen vent line right there at the top. And so these are just air shrouds for ventilation of the plumbing side of the system. Also from a safety aspect, you might be thinking, okay, I'm generating hydrogen at 200 psi, what happens if I get a leak inside the generator? The generator airflow was strictly tested and controlled such that even if you had a full-on onboard leak inside the cabinet, so 200 psi, 228 standard cubic feet an hour, the airflow rate pushed through that generator through the plumbing cabinet is such that when the air exits here, it's below 2% hydrogen and air. So you're below 50% of the flammability limit of hydrogen and air. So there's no concern about any buildup of a hazardous environment inside the cabinet. And of course, monitoring of combustible gas is done. Monitoring of pressure inside the cabinet is also done by the control system. So if the fan was to stop working for some reason, you'd have an initial and immediate indication that pressure is lost on that side of the cabinet and the unit would automatically shut down for safety purposes. So safety is obviously the top priority with hydrogen, and included in our generation systems. Quick overview of the stable flow system. The site is actually out in Utah, and the main power coming in here, data connection line up to the DCS, instrument air to maintain pressure within inside the electrical enclosure, hydrogen sample line coming from existing infrastructure, and the hydrogen vent line going out to existing infrastructure. The stable flow system is designed for Class 1 Div 2 applications, so if you had a site, you want to install one, and the particulars were that the best place was to put it in a Class 1 Div 2 area, they're completely compatible with that type of area for the stable flow system only. The hydrogen generators cannot go in a classified space. So here's some pictures of installation. This is the FPL site in Florida, small generator and stable flow system, kind of basically in parallel with the existing hydrogen monitoring equipment. Morant facility in Michigan. Again, mid-sized generator and stable flow system. I'm sorry, this is in Maryland, not Michigan. Apologize. This is in Dessa, Spain. They have hydrogen generation